So I'm trying a new presentation technology, so bear with me. This is, I can't even remember the name of it. I actually rewrote my presentation this morning using this, kind of a bad idea. It's based on GitHub. GitPitch is what it is, GitPitch. Using Markdown, and hopefully it doesn't look too bad. But how many API developers do we have in the house? This is, I think, really for you guys because there are a lot of pain points that in our several years of developing APIs at MBO Partners that when we came across this, it was like, whoa, you can do that? So that's what we'll talk about today, GraphQL, and this is really meant to be just an introduction. We'll get into the different types of requests that you can make, queries and mutations, and I'm actually left mutations off. It's most of the literature that talks about GraphQL really does not go into mutations, but this is just kind of meant to be an introduction to GraphQL. Really, I used it kind of to bone up on GraphQL myself. We're probably going to roll this out as a technology, part of our technology, and access to our backend APIs. So let's get going. Let's see. Click on that. And it's not, oh, hitting the wrong button. Okay, so about me, I've been in the area for forever. I've been at MBO for 7 years, and I work on the backend API team. And we serve several different clients, mobile, web, and we also have a legacy system that we use the APIs for integration. We're also using the APIs and other ways for integration for getting data from external systems in and out of the system. So we have several different clients, a lot of competing interests. Usually right now the driver is mobile, and they seem to think that the APIs that we're developing are just for them, and that is kind of where some of our pain points come from. The wrong button again. So why GraphQL? When I thought about this, the thing that popped into my head is this line from a movie called Fight Club. This line has stuck with me for years. I think Fight Club's almost 20 years old. But this line stuck with me. They're sitting around the table and somebody's demoing software. And this guy's, his most important thing, not does the software work, is can I get this icon in cornflower blue, whatever that is. And that's always kind of stuck with me, and that's kind of the things that I see working with several groups that are depending on my APIs. They want to know, can they get the thing that they want, and they don't really care about the overall API. It's just what they can get. So to answer the question, why GraphQL, decided to kind of go through a thought exercise. Is anybody here using GraphQL right now? Awesome. Means I'll sound like a expert. You might, when their APIs, they're using REST. Everybody's, I mean, that's what we use, RESTful interfaces. So I thought it'd be an interesting thought experiment to kind of walk through requirements and implementing those requirements using REST, and then also implementing those using GraphQL. So the requirements are we need to build a UI to show information about Star Wars character. For example, Darth Vader and all the films his characters appeared in. This view should display the character's name, birth year, planet name, and the titles of all the films in which they've appeared in. So right off the bat, when I look at that, at least in my head, the way that we approach microservices and APIs, so I'm looking at maybe several different resources. The first one would be I need a resource maybe to get the characters from, maybe another resource to get the planet, and another resource to get the movies. In my head, I think of those as separate, okay? And that's how I chose to implement this in this thought experiment. So in the requirements, whoever's building the UI, they want, there's the food, guys. They want data back in a particular format. They want to be able to get the data back in this format because it's easy for them, right? That's usually the conversation I have with our mobile developers or whoever actually is consuming our API. It's like, why can't we get the data back the way we want it? And so in this particular case, the data is wanted in this particular format. And as you can see, the first couple of lines there, we're bringing back character information or the person resource. That would come from the person resource. Planet information obviously would come from the planet resource. And then we have information about the films. So the title and whatnot about the films. So let's look at a RESTful approach. So if you've been using REST, I mean, this is kind of typically how, if you knew the ID of a particular character, you could pass in the ID to a RESTful endpoint, and you would expect to get back a character. This particular resource, this is the response. So you get back the things that we're interested in. We get back all of this, which is quite a bit of stuff there. The only things that we're interested in actually for our UI are name and birth year. But we've brought back all this other data. So that's interesting. We got the data we wanted. Let's keep going. Actually, let's go back and look at the rest of the data. So in here, we have their home world, and in this particular API, the way they represent that is they have a home world and it's a URL. So that allows me to follow that to go get the additional piece of data that I want, okay? And that's right there. So if I went and called planets1, what I'd expect to get back that particular planet. Again, I get quite a bit of information. I get back what I want, but I also get back all of this other data. All I want is the name, though. So again, you can see that I'm fetching the data that I want, but I'm actually over-fetching data. And that's a concern if you're a mobile, maybe a mobile client where you're trying to be data conscious for your user. All right, so going back, if we were to look at that original JSON that was returned in the response for the character, we would also see that whoever put that API together was very conscious about, okay, they're going to make this call and they're probably going to want some additional information. So they actually did provide links to go get the films. And so that's 4 more calls I need to make. If I pull back that, you can see the data that comes back in that particular API call, which is a whole bunch, actually. The only thing I want out of that, if you remember the requirements, I want to know the title. So again, I'm pulling back a lot of data. So if we recap this RESTful approach, which I don't think is absurd or very outlandish. This is kind of similar to how we build our services at MBO. We retrieve the character by ID. We then retrieve the planet by ID. And then we retrieve the film, another film, another film, and another film. If you add that up, that's 6 different calls. Now, there's strategies to get around that, but there's not a lot of strategies that, I guess you could employ those same strategies to reduce the amount of data over the wire, but that's 6 different calls. So if we said, hey, mobile developer, here is our APIs, there's kind of fair bit amount of work that they have to do. They have to kind of figure out, okay, what am I going to, as a response for this guy, okay, what information do I need from this response to go get the additional information that I need? And that could be 6 different calls or more. That's a lot of calls. And what I hear from our mobile team, and actually other clients that use our APIs is, guys, that's a lot. Is there any way that you can reduce those number of calls? So I'm not really here to bash REST. I think REST is nice. I've actually had this conversation with Ryan at lunch a couple weeks ago. And I think REST is nice. I think it's useful, and we're going to continue to use it. But I think it has some problems. One of the problems is as you add endpoints, and in our head those endpoints have related data, you end up with multiple round trips to get all the data that you need. The reason why we actually stumbled upon this GraphQL is we wanted to come up with a scheme to allow the clients to limit the data that was returned. So we're trying to be a general purpose API and have as much data that we think that would generally serve everybody's needs. But in certain cases, maybe all you want is the title out of a, maybe 100 property JSON response. So we were looking into ways on how to limit the amount of data that came back. Also with RESTful APIs, versioning is kind of tricky. There's lots of strategies that people talk about that address versioning. But again, we're back to that first bullet point. A lot of times versioning ends up being another endpoint in your services. And then that's just something that you have to maintain over time depending on how long those live. So the question is, and this is, of course, rhetorical, can we reduce the number of calls? And yes. So let's look at the GraphQL approach, okay? Again, we wanted to bring back a character, their name, I think their birth year. We wanted to bring back the planet that they were born on and then the film that they had appeared in. So GraphQL works like this. You either submit a GET or POST request, and the query is sent in that one request. And you can get all the data that you want that's available in that one request. So let's take a look at what that might look like for our particular problem. So here, this is a GraphQL query. Here I've got a person, and I'm passing something into it. Looks like some type of argument. And then I'm really describing the data that I want back. So I want the name, the birth year, the home world, the name of the home world, and the films, and the title of the films. So that's very succinct. It's probably a little bit more verbose than each individual REST call, but it is very interesting because this is describing and specifying the data that I want back. So if I was to issue that against a GraphQL server, I might see a response that looked like this. And this is actually a response that I put together. So again, if we were to look back at this looks a lot like the request. I've heard people actually describe this as the question and the answer. So basically, this is the question, and then this is the answer. But the answer actually sometimes will lead you back to the question, kind of like Jeopardy. If you know the shape of the data that you want, then really all you have to do, if you ever to look at this, is to chop off the answers. The answers would be the actual values that were returned. So if we recall what we wanted originally in the requirements, the data that's returned using GraphQL looks a lot like what we wanted. Again, we're not overfetching data, we're just fetching the data that we want. And when we've demoed this to our client API users, they are just like, whoa, when can we use this? This is not in production yet, but I can see how this might be helpful. So revisiting why GraphQL? Well, because typically using RESTful interfaces, you encounter multiple round trips to get data. And this is not limited just to, say, a mobile developer or client developers. When we do integrations, we're primarily the ones that do integrations. We're having to do this a lot. So we're having to go fetch this. Oh, we got this ID, now we have to go fetch this, and we have to go fetch this. And we're making maybe 5 or 6 different calls just to build up the data that we want. It also decouples the clients from the servers, because now the clients aren't told what you're going to get. They actually specify what they want. And that also ties into the last bullet. They get what they need. So again, if they need this set of data to build their UI, that's what they get. All right. So what is GraphQL? So we answered why maybe there's a need for it, but what is it? GraphQL, a lot of times I have this tendency to just stop here. It's a query language for your API. So I think that's enough for a lot of people, especially if you're a client developer, right? So you're using an API. It's the query language for the API. But it also is a set of instructions on the server on how to execute those queries against a type system that you've set up. So it's kind of this little DSL that you set up against your system. As I mentioned before, the requests are either queries, so that's reading data, or mutations, and that's changing data. We're not going to actually get into mutations. Again, I don't really see a lot of talk on how to mutate your data. Seems to be a lot of information on how to query the data, because that's kind of exciting. GraphQL it's a lot of times you think of graph databases. It's not related to a database or storage engine. It is basically a way to think about your data in graph notation. I mean, in my head, that's what I think about. But as you think about data, you have these disparate resources, and in your head, and actually logically, they are related. Those resources are tied together, and if you think of graphs, they're tied together by particular relationships, and those relationships are edges. The resources, particular resource would be a node, and then those relationships would be edges connecting those nodes. And the great thing about GraphQL is that it is really backed by your existing services or data. So you don't have to go throw away all your RESTful microservices or your APIs. It can actually leverage those. And you can place those beside and give an alternative way to access those APIs. And that's the strategy that we're probably going to employ at MBO. All right. So queries and mutations. I should just change this to queries because we're not going to talk about mutations. But queries. All right, so this is a simple query. And I'm going to, let me drop out of this and actually pull up. We're going to talk about this in a bit. Let me fire up my server. So this whole presentation is, if we lose internet access, it's done. Oh, we're not going to look at that. Not today. Not right now, actually. Maybe later. Okay, so let me refresh this. All right, so GraphQL, and we're going to talk about this a little bit more later. Does everybody see that okay? Not sure if I can make the font any bigger, but you can see this interface here is called, I think it's called Graphical. And Graphical is a IDE to test out your queries. And it works like a lot of IDEs. It allows you to look at what types are available. And what it did is it went to the GraphQL server that I have running, and it brought back the schema. And you can see that over on the right here. So let's look at the query schema. And here I can see all the types. These are all the types that are available, or the fields that are available on this root object type. And if I wanted to, I could drill into these, and we'll talk about objects and the fields in a little bit. But I just kind of wanted to show you this, that it's kind of strongly typed. So it goes out and gets the schema, and then what I can do in this editor, if we go back and take a look, I believe that first one was, we wanted to look at person and name. So let's see, hopefully this works. So you can see it types ahead for me. And if I was to execute this right here, this would fail. Oh, no, it wouldn't. It actually, if you see there, it actually put an ID in there for me, because I guess that's the least query that you can do. But in the example, I wanted to see name. I can do a control space, and then it shows me all the different fields from here. So let's go get the name, and if I run that, what that will do is hit the GraphQL server. It basically validates and executes that query and then sends back the data in the shape that I wanted. If I wanted more data, let's say gender, because I haven't tested that one. Let's see if that works. It does work. Okay, so I put in gender, and it gives me a different result. Okay. little more interesting query would be, I want to see the films. And we saw this a little bit earlier, but I want to see the films that this particular individual was in. So if I add films here, I have to tell it what films or what fields from films I want to be available. So let's see what's available. Okay, there's title. And on this one, because I'm anal, I like commas. Commas are optional. And I want the episode ID. So let's run that and see what happens. And hopefully it works. And there it is. So I changed the data that I wanted for whatever reason, and I get back what I asked for. And what's happening here is that films is a different resource. And so it's actually looking at the data returned on the person object and using that data to follow the edge to films, bring back that data, and then send back the shape that I requested. All right, so I think that's awesome. When I saw that, I was like, well, that's pretty cool. It also can handle arguments. So what if I want a particular person? So I'm just going to copy this, make it a little easier. Well, if I know that person's ID and I've exposed this in my schema, which I have, then I can ask for a particular person by passing in an argument. So here I'm going to pass in an ID of 20. And then in this particular case, I want their name and I want their height. So let's execute that. And oh, I do. Thank you. It should know that.
Winter is coming.
Winter is coming. It's already here, isn't it? All right, so for this particular one, ID 20 is Yoda, and his height is 66, whatever that means. It's actually meters.
Kenyatta, in your previous example, how did you specify Luke?
Oh, how did I specify Luke? That's a good question. So whenever you specify an ID, you have or an input parameter, you have the option of defaulting that to a particular value, and in that case, I just defaulted it to 1, which is Luke. Yeah, good question.
You do that on the server or in the school?
It's done on the server, but you can also do that locally. We'll see.
If you didn't default that, would that give you a list of everybody on the system?
If I didn't default it, it actually will just bring back Luke, because that's what the server is going to do. If I wanted everybody, then there is another field that I can use, which is all people. All right, so if I change that to all people, this will take well, it didn't take too long. And that's actually not all people. The reason why I need the internet is because this GraphQL server actually has no data. It's actually hitting another service that's providing the Star Wars data, and they have some funky paging and stuff. So, yes, it is, the arrest. Exactly, it's exactly what's happening. So all people will bring back an array of persons, and then I can specify the data that I want for those records that come back. Okay, any questions about that? All right. If I wanted multiple arguments, you can do that as well. I don't know if that's that interesting at this point, but we'll try it. So in this particular case, for height, before I just specified height. This time, 66, I don't understand that. You know, I want it in feet. So when I do it like that, it brings back the Yoda is a little over 2 feet tall, which is, that's kind of small. I didn't think he was that small, but he's a little over 2 feet. And so that's, again, something on the server that I'm passing, hey, I want this back in feet, and the server is like, okay, I can do that. Let me go get the data, transform it, and then send it back. All right. Aliases. So suppose I want to query person more than once. For whatever reason, I need to get 2 people back. Let's try that out. All right, so query 2 people, we get an exception. And the reason why is the namespace inside query has to be unique. So in order to do this, what I need to do is I can alias one of the queries or both of them, and I know that this first one is Luke, and the second one is C3PO. And now when I run it, it works, and I get back the data that I want. In my head, I don't know why you'd want to do that, but apparently that might be something that you might want to do. This one, let's say you're doing the same thing, and I think like the use case in this particular scenario is you want to show 2 people side by side, and you want to show particular information, maybe the same information. So in this particular case, we've aliased the query so that they don't collide, but you can see we're duplicating ourselves here. Well, GraphQL has a built-in way to prevent that duplication. It's called fragments. So I can define a fragment, and I can define it on a particular person. So again, we're back into this typed business where, okay, this fragment, I'm going to call it this, and it's going to be based on person, and I'm going to have these particular fields. I want these fields, so whenever I build my query, I can use the fragment notation to actually specify the fields that I want.
Is that fragment defined as part of the request payload, or is that defined on the server?
It is defined as part of the request payload. So there's the request. And there we are. So we have the data that we requested, and we did not duplicate ourselves very much. Okay. All right, let's see. Variables. So in particular cases where you want to specify a query and the client doesn't want to rebuild that query every time, you can use variables. And this is how you do that. So I'm just going to copy this whole thing here into here. And this does not go here. I don't think I mentioned, as you can see there, I have a comment. So comments are allowed. So here, if we were to look at this, we've got a query, and this particular time we actually named it. It's named character and movies. And this is our variable notation. So I have a variable called person ID. And then right after that, I have the type of that variable. And then here, I'm using that in my query. Down here, in this variables block, which is sent separately in the payload, I'm defining the variable value. So let's run that. And variables are invalid. Oh, maybe you can't have that down there. Let's try that again. All right, so there is the data returned using variables. I believe the next one is what, Jason, you asked about. What if I wanted to default that? So maybe I sometimes will send this, sometimes I don't. What if I want to default that? So GraphQL, the specification, has a way to do that. So it's just probably easier to just modify this. Okay, we want that to be 2, and then down here, we're going to blow away our variable. We run that against the server. You see it picked up the default because we didn't pass one in. If I define, I'm sorry? First ID for a variable as an array of strings? So there is a way to pass in objects that are not, these are scalars in the language. You could pass an array and then you could act on how that works. So if you, I don't think so. I think because it is, and we'll see what's back in this in a bit. I think that it would probably barf on that because it's expecting a string. It's tightly tied to a method.
Can you talk about what's happening in the query response variables? You have a separate window of model.
I'm sorry?
Can you talk about what's happening in the request and the response of the variables, or the request action? Is that part of the same request, your lower window?
Oh, this window here? Yeah. I'm sorry. So if you can't see that, that actually says query variables. So in the payload, it's segmented as your request, your query request, and then there's another segment of the payload that's just for variables. And that's what that is. If I hadn't just got off vacation and spent all night working on this, I'd probably show you the difference or how it actually worked from, say, a curl perspective. But it is segmented, so you can actually do a get or a post, and it just segments the payload. That's all it's doing. Any other questions about that?
We don't mind waiting if you want to fumble.
I've fumbled enough.
How is it structured, the payload? I mean, can you show an example of the payload structure? You have that available?
Oh, yeah. That's actually a little bit later in the presentation, but just using Jackson to marshal a Java object is all it's doing. But I'll show that in a bit. Any other questions? Okay. All right. Directives, we'll probably skip this one, but you can add directives. So in cases where you want data returned variably instead of having to parse the response, you can actually pass a directive in the query to say, well, I don't want films if this particular directive evaluates to false. And so that's what's happening there. Unless anybody wants to see this. And that is, actually, we'll run through that one real quick. That is the last one, actually. All right, so here I'm passing with films. I'm saying that I'm setting it to false. And, oh. I do have to put that down here, huh? Let's see. I also have to specify a ID. So let's do 19. I don't know who that is. And then let's see. Whoops. Let's get rid of that. All right. Porkins. All right. So that There we didn't return the films because we have the directive set to false. So if we set it to true, it should know what I want. There it is. So setting that directive to true gives us the films. So it gives us a way to control what the data, or how the data comes back, a little bit finer grained depending on maybe the data that actually comes back. There's also, in addition to that at include. So at include, if that evaluates to true, and I think there's at skip on, which if that evaluates to false, I think they're opposite basically. So that's that. So that's the queries. No mutations. So schemas and types, there are, from a queries perspective, and actually still from a mutation perspective, there's a root object, and the root object, and I didn't really understand this when I first started looking at this, it's kind of the jumping off point to get at the data that you want. And then there are object types, there are types, kind of what you would think, and fields. A object type is pretty much a Java object, and a field is a field or property. There are scalar types, and the scalar types are integer or int, float, string. I think the float's double precision, I think. Boolean, and then there's a special one that's used for caching of data, and we'll talk about that in a second, why that's kind of something that you need, and that's ID. And then I guess optionally, depending on the implementation, you may have date. And I don't think I mentioned this before, but this GraphQL is a specification. It's implemented by a lot of different languages. So it's not specific to Java or any particular language. And so that's why date and how it's implemented is it's specific to the implementation. Are we going to eat afterwards?
Yeah, I'm going along with that.
Oh, okay. All right. All right. Schema and types, again, there are other types. There are lists. There are interfaces. And these are like Java interfaces. You can define an interface, and whenever you have a object that basically inherits from that interface, it has to implement the things on the interface. And then input types. So if you need something a little bit more beefier than just a scalar, you can use complex types to be passed in as arguments. And let's see, what's next? GraphQL and Java. This is the Java user group, right? So we should talk about Java a little bit. So there are several tools that I use actually to build the server that I'm demoing today. And it's primarily built upon, there's GraphQL Java. And this is the big framework out there. This has probably the most love from developers. There's a lot of projects that are built around that. There's another project that popped up, I think last year or maybe the year before, called GraphQL Spring Boot. So if you use Spring Boot, this is a auto configuration that you can drop in to get support in Spring Boot for GraphQL Java, as well as graphical. There's a auto configuration for a graphical. You can drop that in, and that will be served in your Spring Boot application. So the GraphQL Spring Boot was actually forked by the GraphQL Java guys because the guy that came up with it, this O.M. Bedler, just kind of fell off the face of the earth. And it was pretty popular, and so they've forked it, and it's now under GraphQL Java. Well, the GraphQL Spring Boot uses GraphQL Common, and the development, like the Spring Boot project, is just kind of stopped. It's not being maintained. And the GraphQL Java guys have, they've dropped support for it, at least temporarily. They're waiting on somebody, I guess, to pick that up and kind of champion it and keep it up to date with the rest of the GraphQL Java stuff. And then also graphical, that was the tool I was using. This is a standalone tool, which I kind of like because I can add headers, and that comes in handy. But if I was to go to my browser, I could actually show you it running in my browser, I think. There it is. So I could run it in the browser too because I have the auto configuration set up there. Okay. All right, let's see. All right, so here's some Java. So in order to get this to work, and this is actually the whole file, I think. So this is to define a schema. The GraphQL Java guys take a different approach, which I think kind of sucks, is they use a builder, and it's just gigantic trying to build the schema. The Owen Bedler guys like, I'm just going to use annotation. So as you can see, you can define a schema there, and on the schema there are two objects. There's the root object, and then there's also a mutation, which I guess in the GraphQL Java implementation, you have to have the mutation, otherwise this will not work, which I find very stupid. So I had to add that. That doesn't actually do anything. But you can see there's the GraphQL schema annotation that says this guy is going to act as a schema. And I think you can have multiple schemas on a GraphQL server. And then you can also specify this is a query. So here's the root object type, and this is where I'm going to do my queries. And then down here you can see this is the mutation. And then you can see there's other annotations there, like adding a description, and then there's also this GraphQL in, which I'll talk about in just a moment. Okay. All right, so this next class is, this is my root object type, so this is the root of my schema. So this is how I get to everything that I want to do. And as you can see, here's all films. We have film, the ones we were using, all people. So this is the definition of all people. And forgive my duplication in here. I normally don't like that, but was pressed for time. Here is how I get one person, and there is at GraphQL in, so that's the ID that I can specify. Let's see, let me just step through here. So here, this GraphQL object, that's how I specify an object in GraphQL. And there's nothing really special about this root object type other than I have it hanging off of the schema. And that's how I get to everything else. There's also this field type. So for all fields, or all films, you can see this is what I'm doing. Nothing really fancy. The particular API that I had to call, or that I'm calling, there is, for some reason, you have to send a user agent, or you get a 403. That's the only reason I'm building that up there. But it's just a REST call, and you can see where it's going. Pulls back the data, and then just returns it as a list. And to your question before, just Jackson's marshalling it into JSON, and I'll show you some of that too. Okay, here's another object type. This is actual one for person, so you can see nothing really different from the root one, other than I get to person from root. This is, I think, what's kind of interesting. So this is kind of serving two purposes here. One of the purposes is I was being lazy and using the same object to actually marshal the response from the Star Wars API into this object, and then I was using the same object to return back through GraphQL. Typically, I probably wouldn't do that. I'd probably create two different objects and copy the data between the two. One of the things that's interesting is this annotation here, this at GraphQL ignore. By default, GraphQL is going to take every field on a bean and expose it as a field in GraphQL on its type. But if you tell it to ignore it, it will ignore it. So I have that one ignored because later here, I actually overrode, that's on film too, huh? Overrode, yeah. My wife will be like, you can't, grammar. Here I overrode height, and when I call height, I do this transformation on it. So in GraphQL, I think kind of the idea is you have these discrete objects or resources, and to get from one resource and follow the graph to the other one are these small little bits of code. And this is, I think, pretty small. I mean, all I'm doing here is if you pass in feet, actually, let me go back to this GraphQL in. So here I'm defining an input variable, and the default is meters, is because that's what is sent back in. And the guy who implemented these annotations thought that it was a good idea, I guess, to use spell for evaluation. But I'm defaulting it to meters, and then it comes through and it gets the height. One thing to note here, actually, let me scroll over here. This data fetching environment. So if you're traversing a graph, you don't have access to the object that you're on, and you have to actually get a context. That's what this data fetching environment is. And that gives you the context of the object that you're actually on. So I couldn't just call get height here because it wouldn't work. I have to get it off the context of the thing that I'm on currently. And that's what I'm doing here. I'm getting the person type from the environment. And I called that particular field height in centimeters because that's what it returned. And then I have to do some checking to make sure that I can convert that. And if they passed in feet, then I have to then do a conversion to feet from meters. Let's see. That's that. So with great power comes great responsibility. I think GraphQL gives us a lot of power, but it can be problematic, I think, if you're not careful. So one thing you could do, and I did this very, very soon, I'm like, oh, I've got this graph. I can go from this guy, this node, to this other node, and then I can go back to another node, and then go back to another node. I can go back where I came from. You could just keep doing that. Well, eventually, if you did that enough, you could probably bring down a server. So that's kind of a concern, and there's different ways you can combat that. You can do query analysis and compute a score on the query to see how complex it is, and then just deny ones that are too complex. So they have a whole bunch of jumps in them. You probably, you might not want to allow that. The other way you combat this is you might not allow your GraphQL interface out to the public. Maybe that's just a private thing. So there's different ways that you could combat that. Another thing that we ran into is authentication and authorization. In everything that I've read and kind of the way that we've approached it at MBO is we're not going to deal with that. We've got other APIs that this is using, and all our authentication authorizations on those. So if this is the reason why I like this other this standalone graphical is because I can pass in my authorization headers, my bearer token, and it just passes it down to the servers or to the services that it's calling. me go ahead and make this bigger. Sorry, guys. Data caching with REST, one of the things you kind of get out of the box is the ability to cache, right? That's something that HTTP is known for. With GraphQL, it's different, right? You're doing a post, and you're not necessarily able to cache the same ways. There are caching mechanisms set up. There's one technology called Relay, and it uses, anytime you access an object, it assigns it a unique identifier. And then it will, if you ask for that object again, it will go and retrieve that same object with some certain time to live. The other thing is paging. And that Relay kind of addresses that as well, because, or connections, another technology called connections. If you bring back, say, everything, you might not want everything. You might want to be able to get that in pages and control that from the client. So that's another concern. It's not necessarily just built in to GraphQL. All right, who's using GraphQL? Well, GraphQL was developed by Facebook, and they released it, I think, a couple years ago. And it's kind of catching on. A couple months ago, GitHub announced that they were going to switch their APIs to GraphQL, Pinterest, Intuit, Coursera, and Shopify. Just a few of the companies that are using this. Resources. The first one is GraphQL specification. Lots of information there. There's the GraphQL Java, Spring Boot. There's still Embedler out there, so if you're feeling adventurous and want to jump into a open source project and maintain it, that's out there still. My presentation and the server is the implementation, the Spring Boot implementation is under my GitHub account there. And if you're wanting to look at the Star Wars API, there's their RESTful API, and then somebody put a GraphQL API in front of it. Questions?
Have you worked with Mutations through this?
I haven't. I wanted to do that and actually talk about it today. But everybody, not everybody, but a lot of the places, as I was doing my research, there's not a lot of people that even talk about it. I think a lot of people are really excited about the query part of it. The mutation part, I think, looks pretty straightforward. The thing that, when I first considered mutations, is if you're able to follow this graph, that seems very complicated when you're trying to change data. If you're going through it, it seems a little bit more direct to maybe just use your, whoops, sorry guys. Looks a little bit more direct, or seems a little bit more direct just to go to the RESTful API, just to, or your base API and make the change.
Is that what people are doing, querying the GraphQL?
It appears that way. Again, I'm not an expert, just now getting into it myself, but that's what it seems like.
I don't know if he's done the mutation stuff, but you might talk to Jesse Harlan, who's been doing a lot with this lately.
Oh, really? Okay. Yeah, it would be good to talk to somebody else that's been maybe doing this and see what their maybe pain points, because I imagine there are pain points that I just haven't seen yet. Any other questions?
On the schema, I mean, is there an equivalent of like Swagger?
So I think the schema, if we go back and look at that, I don't know how easy that is to see. There isn't, but I mean, you have some things that are kind of nice, like searching. There is if I wanted to look at the schema, I think, if I went here, I think I could go here maybe. No. Nope. I think there's a way to look at the schema. And so if you're trying to reverse, there's actually tools that will allow you, so I assume you're talking about Swagger in the terms of being able to do code generation, or just, yeah. So you can do code generation. If you're into that type of thing, where you're doing schema first, I hate schema first. But I know a lot of people, that's where they start. You can actually start from a schema, and there's lots of tools that will allow you to start with the schema and then build your objects and your GraphQL server that way.
I imagine it would be, once you have your schema set, should be really easy to mock out this data.
Yeah, it should be very easy, actually, after you've got the schema set up. I guess I just do things wrong. I hate doing schema first. I had to do that a couple years ago, and then we were supposed to do that, and then everybody else wasn't but me. And they were just banging stuff out. So I've kind of gone away from it, but there's a lot of value in doing that first because you kind of know where you're going. I think if you already have an API, it shouldn't be too big of a leap to go from that API to some type of schema.
Do you find server-side implementation more complex than a typical REST service?
Actually, no. So let's see, if we wanted to, how do I switch the colors? This is interesting. Themes.
It's right there.
Oh, sorry. All right, is that better?
It is.
All right, so let's do this. Close all. So here's the application. We've got 1, 2, 3, 4, 5, about 9 maybe classes. The application, there's nothing there, right? Yeah, it's just a Spring Boot. The schema, that's the schema. So that's basically defining, this class is going to be the schema and define what's on the schema. And if we follow that to the root object type, right, there's a lot of repetition there, a lot. So, I mean, that's doing quite a bit, right? So it's going out, and these guys are off the root, so I can get all films, again, one film, all people, one person, all planets, one planet, and it's just making a REST call, bringing it back, and then boom, it's in there. And then if we were to drill down into one of these guys, I mean, they're a little more than a POJO, not much, right? So here I can traverse from a person, this defines the edge from a person to films, and then the edge from person to a homeworld. So, I mean, we're not really talking about a whole bunch there.
Does that integrate very well into just a plain servlet environment?
I would think that it would. The actual GraphQL Java implementation is just a servlet. Yeah. I'm sorry? How's the data stored? So in this particular implementation, I'm not storing any data. It does do some caching in memory, and you could probably get as advanced as you wanted to be with that. In this particular implementation, and the way I foresee using this is I would have a GraphQL server, one server, and then as I wanted to bring resources online, I would just add that to my schema, and then those would just be RESTful calls. So it doesn't store any data. I mean, you certainly could, but I think the idea is that you connect to other things, and most likely things that already exist. Sure, yeah. If you wanted to back it with SQL, any type of data store, you could back it. I kind of think of APIs kind of as data stores, kind of, right? And so it can hit data stores. However you want to get your data, you could just serve it up as from a text file or a list in Java, however you wanted to do it. It really doesn't care. Yep, you just write a schema and return those objects. Any other questions?
How do you handle evolving the schema?
So we haven't got to that problem yet, but I have read up on it. So according to documentation, they say evolving the schema, it should be easier, right? So if you want to expose more data, I mean, you obviously can't take things away that people are using, but I think because of the nature of whenever I'm a client, I just get the data that I want, right? So unless I'm changing one of those fields for that client, I don't really have to worry about versioning so much, right? If I want to expose more data, I can do that, and that doesn't affect any clients.
But if 5 years from now you decide, you know, everybody should migrate off of this new property and you want to remove some code from the server just for cleanliness, but you've got a client that still requests that particular attribute, is it going to explode?
Yeah, so the query that they sent would not, it wouldn't be valid, right? So they would know right away that it didn't work. So.
Talk about multiple schemas. How does that work in practice? Is it, what does that look like to the end user? Does it get different REST endpoint or different endpoints, or?
I don't know. I haven't tried it. I think that you can do it. I don't know what it would do. I mean, we could try it maybe after some people get some food in them, and we can try that out and see what it looks like. So they have different schemes for, the question was the ID, the specified ID. They have different schemes that you can use. So it would be local. It's just an in-memory ID. But you could probably come up with a way to, if you needed to distribute that across servers to make that happen. No, it's not permanent. I think, how many people use UUIDs? Yeah, so I mean, we are moving to UUIDs. You could use your UUID and from whatever data store that's from, because it has to be globally unique or universally unique across the application. So that would be, and you could use those, but in general, I think out of the box, when you add that in or use those IDs, it just comes up with some unique identifier, and it is just in memory, it's not persistent. Anything else? All right, thank you very much.